Hello everyone, Abhishek this side, and today I'm here to talk about stacks. Okay, so before talking about stack as a programming language, let's try to know about stack, what stack actually is in daily life. Okay, so to start with stack, I would like to take an example of a pile of books. Okay, let's start with the example of a pile of books. So how do a pile of books look like? Let's say if this is my pile of book and here my books are kept like this: book 1, book 2, okay, book 3 and book 4, right? So this is the pile of book, or I can say a stack of book. Stack basically means something which is kept on something, one on one, right? So here I have kept 4 books, and the book 2 is present on book 1, book 3 on book 2 and book 4 on book 3, right? So here, let's say I give a scenario. I want you to take out one book out of this pile. Okay. You want to take one book out of this pile. So how will you take the book out? Can you take out this book number 3? No, we cannot do that, right? Because if I have to take one book out, I can pick it from the top of this pile. I cannot pull it from this downside, or I cannot pull any book which is not present on the top, right? If I have to remove anything, I would have to do that from the top only, right? This thing is very much clear. This is the first scenario. If I have to remove a book, let's say if I have to add one book, this time I have to add one book. Now if I have to add one book, can I push it between 3 and 4? Can I push the one book here? What you usually do if you have to add one book onto this onto this pile, so you will go and put book number 5 on top of 4, right? You are going to do this thing, right? So in this way we get to know that if either I have to remove an item or I have to add an item, what will I do? I'll simply do it from the top of the pile, right? So this is one observation from the stack. This is one observation that either I want to add an element, right? Add an element, or I have to remove an element. I can do that from top only, top of stack. I cannot do it from the mid. I cannot do it from the bottom. If I have to add an element or I have to remove an element, I can do it from the top only. So this is one of the most crucial observation that we should be knowing. And the pile is exactly the same thing. The pile of book is exactly the same thing that your stack is going to perform. Exactly the same behavior, right? In the programming language also, if we talk about stack as a programming language, then this is going to perform exactly same as this pile of book is performing. Okay, so here what we followed, if I had to add one book, if I have to add one book, I can add it from the top, right? Or if I have to remove it, I will remove it from the top. Okay, so here I can see one observation. Okay, let us just check one observation. Let's say I just added one book, book number 3 here, right? I just added book number 3 here. Initially I had added one, book number 1, book number 2, then I added book number 3 here. Okay, so now if I want to remove a book, if I want to remove a book, which book can be removed? Which book can be removed? Only book number 3. And why book number 3? Because this book number 3 is present at top, right? Since this book 3 is present on the top, only book 3 can be removed at this point of time, right? So we got this idea that anything which is present at top can be removed. So we come to a conclusion that stack follows a property called last in and first out. This property is called LIFO. What LIFO is doing? Last in, first out. Basically, the element which was pushed lastly, the element which was pushed lastly can be removed out first. And this is the only element which can be removed from the first. Like uh, this last element can be removed first. I cannot remove any of the other elements apart from this. So this stack will always follow this property that is called last in, first out. Okay. So these were a few of the important things that we need to know in this stack. Now let us try to understand some of the functions that this stack is gonna perform. Okay, so what are some of the basic functions? So the first thing will be push. Push basically means adding an element, right? Push means adding an element in the stack. The second operation will be pop. Pop will be removing an element from the stack. Removing an element from stack. The third operation will be peak operation. This peak operation always gives the top element. This will always give you the top element, whatever is present on the top. The fourth operation can be, this can be a property which will let you know if your stack is empty or full. If your stack is empty or full, let's say if there are no items, if I have a this can be my bookshelf. Okay, let's take the example of a bookshelf. And if there are no books on this shelf, so what I'll say that this stack is empty. So this function, this is empty method or function, you say, this will just let you know if your stack is empty or not. Okay, so these are some of the important functions which we are going to perform on our stack operation in order to accomplish or in order to solve any set of problem that is given to us. Okay, and there are some inbuilt methods like push and pop in your JavaScript which can be used, but we are not going to use those inbuilt method. Instead, we are going to create our own methods and we will be using that method if we have to remove or add any element. Okay, whatever operation we have to perform, we are going to implement them from our side only. So this was all for the stack as an introduction. And okay, before ending this, let's try to understand some of the major applications. Let's try to understand some of the major applications of stack. If we are learning stack, so why should we learn them, right? So let's try to understand some of the uh, applications. So my first application will be, okay, so before this, I want to show you something. Okay. See, I am on my home page. First of all, I want to go on this LinkedIn website. Firstly, I visited this LinkedIn website. Then I visited YouTube. Keep seeing this. I visited YouTube. Then again, I visited my Gmail. Okay. Now I am clicking on my back button. What happened when I clicked back button? Whatever I opened before this Gmail, I went there. Again, if I press back button, whatever I opened before this, I went there. If I again press back button, whatever I was, wherever I was initially, I am at this position. So now what happened here? My browser is behaving like a stack. Whatever I'm opening. First of all, I was at my home initially. Let's say this is my home. Firstly, I opened LinkedIn. Then I opened YouTube. Then I opened Gmail, right? As soon as I clicked back button, now this Gmail is removed. This Gmail is removed from the stack. What was present before this? YouTube. Now my browser knows that before Gmail, I visited YouTube. Now again, if I press the back button, now this YouTube is removed. Now this LinkedIn becomes top. Now my browser knows I visited LinkedIn before YouTube. So if I open three websites, so is there any way I can directly skip from Gmail to LinkedIn? Is there any way? No, there is not any other way. If I am clicking this back button, I will have to go firstly on YouTube, then again pressing on back, then I will go on LinkedIn. So this is one of the use case that your browser uses to maintain the set of websites that you have opened, right? So this can be the first test case. So what this test case will be, we can call it browser history or browser surfing, anything, right? This can be one test case. And I would like to show you one thing. Let's say if I am here now, this back button is not there, means this is not functional. Why? Because as soon as I am on home, my stack becomes empty. You can see, as soon as I reach my home, my stack becomes empty. There is nothing present below this. There is nothing present below this. My stack is my stack is already empty. So there is nothing to move on. That's why this back button is not clickable, right? So in this way, this is working. Okay, so let's talk about some other application. So what can that other application will can be that other application can be playing songs or yeah, let's take an example of playing songs on any app, on any media application, something like that. So how does your media application look like? There is a pause play button, forward and previous. So let's say if you are playing song one, song A, song, this is your playlist. Okay, this song A is present on top, B, C, D, this way. So if you started playing from this, you clicked on forward button, now you come here, you are started listening song number B, again you clicked, you started listening C, right? So now if you want to go back, you pressed back button, right? So this is again this song, when you started playing this song, this went into stack. If you pressed on this button, this song B went into your stack. Again, when you press this button, this song went into your stack. Now if you pressed backward button, this one, if you pressed back button, now this current song C is getting played. If I press my back button, so whatever is present before this in the stack, this B song will get played, right? This B song will get played. Again, if I press back button, this A song will get played, right? So in this way, okay, let's say at any point of time, now I didn't play D, I directly clicked on E song. I clicked on E song. So after this C, this E will go. So when I am listening this E song and I again pressed back button, this will not go to D, it will directly go on this C, right? Because C was the last song which was played before E. Okay, so that will be basically below this E song in the stack. So in this way, your media applications perform, right? So this is also an important application of stack. One more application can be what can be that application? Okay, so that can be, let's say if I want to reverse my name or reverse any word, you can say, let's say reverse my name. So if I talked about my name, let's say Abhishek. Okay, this is my name. I want to reverse this. So how can I do that? I can take a stack. I can start pushing the elements starting from left direction and moving till right. So how the elements will go? A will go firstly, then B, then H, then I, then S, then H, then E, then K will go. Okay. Now if I have to reverse them, what will I do? Now I will start traversing my stack from the top. If I started traversing my stack from the top, what will I get? Firstly, I'll get K. Then after removing this, I'll come here. I'll get E. After removing this, I'll come here. H, S, I, H, B, A. So now you can see if I just started traversing my stack from the top, I get all these characters into reverse direction. And if I just concatenate them all, This is just the reverse string of my name, right? So this can be one uh, test case which can be used also. So this can be used to reverse your any array, any string, or anything like that, right? So this can be one other application also. So this was all that you need to know about stack to just get started solving the DSA problem based on this stack. We'll just try to solve some important questions also in our upcoming videos. But first of all, we need to implement these functions, right? Because any operation can be performed using these functions only. So in our next video, we'll try to implement these functions like push, pop, peek, and empty, or all these functions. So we'll try to basically implement our stack, our own stack, using our own code. We are not going to use the inbuilt methods from JavaScript or any programming language. We will try to implement the stack from our own. Okay. So please stay connected for the next video. This was all for this introduction. Thanks for being with me till here. Thanks, guys.